Back in my another vector tutorial, we are solving from exercise 13.4. In this stage I'm going to show you question number 6, and it's written here at 12 hours a ship leaves at a point Q with position vector. This is its initial position, and relative to the origin, I mean that the position vector we can write here as a OQ. It is given here. And the next is the ship travels with the velocity vector is given kilometer per hour. Find the speed of the ship. The first question, we all know the speed of the ship means we have to find out the modulus of this vector, which is 6i minus 8j. So this is called the speed. We can write that one as a speed modulus vector. We are going to find out the modulus of this vector, 6 square plus minus 8 whole square, and we would get from there, I think, 36 plus 64. It gives us root 100, and it is 10, one of the popular number in our maths, 6 and 8. Okay, next question is find the position vector of the ship at t3 p.m. B, position vector, if they ask you in a particular, so you can use the vector formula r equals to a plus t velocity vector. Best, this is A stands for initial vector and B for velocity vector. Its initial position is given as OQ, which is 10i plus 38j, and its velocity vector is given here V 6i minus 8j. But before that, at 3 p.m. what is the time actually? It started from 12 hours, then up till to 3 p.m. actually t equals to 3 hours, we can say. So we needed to use here 3 instead of time, and its velocity vector is 6i minus 8j. Just we needed to add the values from there. 10i plus 36 the 18i minus plus 38j, then minus 3 is the 24j. So we can add, which gives us 28i, then plus 38 minus 24, which is 14j. So 28i plus 14j, and this is our position vector at time 3 p.m. So next question C is find the position vector of the ship t hours after leaving. It's very simple, because t hours means we can use the same equation here as well. R equals to its initial position plus t into velocity vector, velocity position. So a value we got from there, which is its initial position, and the value for a initial position, which you can write 10i plus 8j plus time into its velocity vector 6i minus 8j. So easily we can write it by taking I common, which it gives us 10 plus 60, and another one, if we take j common, this is 38 minus 8t, and this is our final position vector in terms of t. C we already have done, and it's the last question. Find the time when the ship at the point with position vector. This is a position vector provided, so we can equate these two value from here. I'm going to use different color now. D part, and it's the most crucial part of this question, or important part, you can say. 60 I into 60 is coefficient of I and coefficient of j, which is 38 minus 8t, and its final position is given 61i minus 30j. Actually this is a vector equation. We can equate from the both side the coefficient of I and coefficient of j. So this is the first one is I, second one is j. Then if we get the same value of t, then we can say at that time it would meet. So let us see and find out the value of t from there. So if I equate the coefficient of I, if it's equation of I, it gives us 10 plus 60 equals to 61 we got from here. And another one, coefficient of j gives us 38 minus 80. Coefficient of j, we are writing here 38 minus 80, which is equals to minus 30. So find out the value of t from here. Let me see what the t value is coming. We needed to use a calculator, because let me use calculator to do that. 61 minus 10 is 51. 51 by 6, so 51 divided by 6, and it gives us the value 17 by 2, which is 8.5 hours. And let me find out the t from here as well, which is 68 divided by 8. We can write directly 68 divided by 8, and we got from there 17 by 2 as well, the same, which is 8.5. So our value of the t is correct definitely, because we got from there both t values are same here, 8.5. After 8.5 hours they will add the position vector of 61 in minus 30j. So it's written here, find the time. So we needed to convert this 8.5 hour actually in hour and minutes. So it gives us 8 hour. Then we can say 0.5 hour. If we convert in the minute, 0.5 into 60, it gives us 30 minutes. So how to write this? So at 12 p.m. it is like this. So we can write here, it started from 1 to 6. So this time we can write at 8 p.m. or we can write 08:30 is our time period in this time. 8 p.m. 8.5 p.m. you can say, or 8:30, the timing up in the 24 hours timing format you can write. And that's our answer of this question.